I knew that thing was going to come down sooner or later. Oh, that's bad news right there.
She's in her basement. It's gonna take all them houses. Oh, I hope she's in her basement.
Get away from the windows! Get away! Get away! Get away! Get away! Get away! Where's everybody? Where's everybody?
What you?
It's going to get that house right there.
Yes, it is.
There it is. There went the barn. Look at that. Oh my God. What? Right there.
You're kidding. Look at this.
Picking it up now. Where's the other one, John?
I don't know.
Go. Shoot it.
You better floor it. You better floor it.
Shoot it.
We're all right. Just stay ahead of it. Get in the left lane, Greg.
Yeah.
Oh, that didn't help us. Go back. You're okay. You're okay. Keep going, man. Keep going.
Faster?
No. Yeah. Lots faster. Lots faster.
Underneath the girders. Keep rolling, Ted. It's coming at us. Keep rolling. Come here. Shove yourself right up underneath them. And hang on to them. Hang on to each other. You're okay. Hang on, you'll be fine. Hang on to the girders.
Don't worry about it. Hang on.
I got you.
That's what you do.
This is spectacular. This is spectacular. We have debris thousands of feet in the air. There are flash fires on all the high tension wires. We're about 3/4 of a mile from the actual touchdown at this time. This is really spectacular. Another touchdown, another touchdown. I'm going to have to leave this area here. The debris is drifting my way.
There was a time when videos as spectacular and personal as these were undreamed of. During the early decades of serious tornado research, there were few motion pictures from which to try to gather clues about this most puzzling and violent creature of the atmosphere.
Oh, come on and drink your coffee, Jesse. You've been standing there for half an hour.
Could you bring it over here, Helen? I've got to keep an eye on these clouds.
The least you can do is sit down.
Thanks, Helen. I got to keep watching the southwest side. That's where most of them come from.
You think it's likely?
No. The odds are way against it, even in weather like this. I've never seen one, but there's always a chance. Weather Bureau wouldn't issue a tornado alert without some good reason.
When the first tornado preparedness film was made in 1956, only 3 tornadoes had been filmed. The very first film was taken at Corn, Oklahoma in 1951. These were actually a pair of tornadoes, possibly rotating in opposite directions. Eyewitnesses stated that the funnels merged at the edge of town and went on to destroy about 25 homes. Other films were taken at Scottsbluff, Nebraska in 1955, where a family of 13 tornadoes kept forecasters and spotters very busy. In 1953, this remarkable piece of film was taken at Warner Robins, Georgia, where 19 people were killed. In some ways, it's unmatched even today in its depiction of buildings being blown apart. Tornadoes in 1953 were among the deadliest in history.
One of the most disastrous tornadoes in modern history slices its way through the heart of Waco, Texas, leaving in its wake a spectacle of devastation described by one military man as that of a saturation bombing of a German city during the war. Military joined civilians in the heartbreaking task of searching for victims in the huge mounds of rubble. Even as these pictures were taken, the death toll at Waco stood at 108, with 10 more in San Angelo, 200 miles to the west. Equally hard hit are Waco's suburbs, where homes and cars are flattened as though by a giant fist. A city of 120,000 is left virtually paralyzed, with salvage pitifully small. The grandstand at the ballpark is reduced to matchwood. Full facilities of the Red Cross are mobilized to care for the hundreds of injured and homeless. The long task of digging out begins with workers clearing the rubble brick by brick, hoping to find survivors. A church feels the violence of the great wind. In a year of record tornadoes, Texas bears the brunt of devastation and tragedy. The weather continues on its spring rampage of death and destruction. Tornadoes, shrieking windstorms born of converging weather fronts and low pressures, strike again. 2 Midwestern states, Michigan and Ohio, feel the fury of the cyclonic winds. Flint, Michigan, hardest hit, 112 dead. Cleveland, Ohio, 8 dead. A 350-mile path of destruction, thousands homeless, damage in the multi-millions. Worse than the London Blitz, one witness said. Another told how the wind tore his baby right out of his hands. Automobiles hurled hundreds of feet through the air. There was little time to escape, no place to hide. The conditions that spawned the Midwest tornadoes were repeated in New England 24 hours later, cutting a 30-mile corridor of devastation near Worcester, Massachusetts. In 5 minutes, the storm changed a pleasant suburb into a scene resembling the wreckage of war. Dazed by their misfortune, survivors search for belongings in the wreckage of their homes. The death toll in the Worcester area has reached 91, bringing the spring toll throughout the country to well over the 400 mark. Can atom bomb tests be blamed for the unprecedented tornadoes? Weather experts say no. Whatever the cause, those who lived through the storms will never forget.
Looks like a bad one. Okay, we'll take it from there.
That year was also an important turning point. 1953 was the last year in which a single tornado would kill over 100 people. Probably not by coincidence, it was also the first full year of operation of the National Severe Storms Forecast Center. Using methods that were first developed by the Air Force Weather Service, the U.S. Weather Bureau issued watch boxes, beginning a system that has been refined many times over the years, but is still basically in use today.
Weather forecast was issued for the Elmville area.
Houses and streets and people.
The modern era of research on the life cycle of tornadoes probably began in 1957. This tornado at Dallas provided hundreds of photographs and over 2,000 feet of movie film, covering the full life history of the tornado. It became the subject of the first television documentary featuring the actual tornado.
On and on the twister moved. Through the Trinity River bottom. North along Riverside Drive. South of Brook Hollow Country Club. Across Harry Hines Boulevard. Over Bachman Lake. At that point, the Black Snout filled itself with a tremendous gulp of water, and with its thirst quenched, it gradually disintegrated with one final blast at some homes along Northwest Highway. Disaster Dallas.
A few months later, detailed studies of a tornado at Fargo, North Dakota, were begun by Professor Fujita of the University of Chicago. 10 people were killed here, the same total as at Dallas. The massive funnel damaged or destroyed over 1,000 homes, twice as many as the smaller Dallas funnel. Fujita's research was the first to focus on the position and movement of the rotating wall cloud. And he refined the concept of tornado families. His animation of the weather conditions at the time of the Fargo tornado, and his development of other visual techniques were just a few of the many pioneering efforts in 1957.
Let's take a look now at these clouds as they are forming in the distance. This is looking toward the west-north of the Channel 6 studios. You can see a great deal of turbulence in these clouds. They're dipping, falling, rising once again. There's also at the bottom of the screen, or just above the ground, quite a lot of smoke pall. I don't know what that's from. All in all, it looks now as though we might just have rather severe conditions on our hands. Now, as we have...
It wasn't until 1964 that a tornado was captured live on television after a hook echo was sighted on the television station's radar screen at Wichita Falls, Texas.
The funnel appears to be moving away from Wichita Falls proper, but is now, at the moment, apparently very close to Sheppard Air Force Base. We have quite a lot of confusion out in this area, not only at the station with people wondering what's going to happen, but a good many cars stopped along the Seymour Highway.
Yes.
Can you swing around and get that, please? A white rope effect. Very definitely that funnel is still with us, which is right above, possibly just beyond Sheppard Air Force Base. That is still a funnel, Jack, and a big one.
The funnel eventually ripped apart about 500 homes and killed 7 people. Between 1957 and 1971, there were hundreds of destructive tornadoes, but only a few were captured on motion picture film each year. Very few were in color. This film of a tornado at Perrin Air Force Base in Texas has been used in dozens of educational films. It covers almost the full life history of the storm, including the first rotating clouds. Through the mature stage, to the final rope stage. The location and date of some films were not accurately recorded for posterity. This was probably the Dallas tornado of 1957. In 1966, not far from Mount Rushmore, South Dakota, time-lapse photography of a 10-mile-high thunderstorm accidentally captured the formation of a tornado on just a few seconds of film. Hundreds of trees were snapped and 5 campers were injured in a pickup truck. Also in 1966, this funnel at Topeka, Kansas, set a new record for damage. It was history's first $100 million tornado. It also ended the myth that Burnett's Mound, at the southwest edge of the city, offered some mystical tornado protection.
This is Topeka, Kansas, and this is the aftermath of the most destructive tornado ever to strike the state capital. It sliced a path of death and damage a half-mile wide and 15 miles long. 17 were killed, 3,500 people were homeless, 500 homes and 50 businesses destroyed. Damage estimated at $100 million. Automobiles were tossed about like toys by the tremendous force of the twister. An old Indian legend which says Topeka is safe from tornadoes because it's situated in the Kansas River Valley was also destroyed by the vicious wind. After the storm, the city looked like the result of a massive bombing. Schools were pressed into use as shelters for the homeless. Casualties would have been higher had not civil defense sirens screamed a warning 15 minutes before the tornado hit. Many people fled to their basements. The area hardest hit was the campus of Washburn University, where every single building was damaged or destroyed. Damage here alone was estimated at many millions of dollars. Every tree on the university grounds was down. Roofs and top floors of buildings literally disappeared. The new Student Union Building, Law School, Math Building, Gymnasium, and Chapel were among those leveled. 4 sorority houses lost roofs and walls. Fortunately, Washburn's 5,000 students had been dismissed for the summer just a few days before the tornado hit. School papers and books were found as far as 65 miles away. Masses of rubble, aftermath of a killer storm.
The era of black and white tornado films ended in 1969, as this tornado passed from Perkins to Ripley, Oklahoma. The towns were spared, but a dozen farms were torn apart. It was also in the mid-1960s that scientists began to seriously explore, indirectly, the interior structure of tornadoes. For instance, 2 scientists, one working with photographs and surveys of tornado damage, and the other working with a tornado model in a laboratory, gave us a better understanding of what we now call multiple suction vortices. After studying hundreds of damage photographs, Professor Fujita suggested that some of the Palm Sunday tornadoes contained not just a single vortex, but a set of what he called suction spots. These were multiple vortices inside of a tornado that rotate around the center of the main funnel. He suggested that these so-called suction spots were responsible for the complex damage patterns in many large tornadoes.
Badly injured, and authorities estimate the damage at more than $10 million. Many such towns were caught unaware, as one tornado would bypass the populated areas, only to have another hit from a different direction. In Marion, Indiana, the storm there struck 4 widely separated areas. One block would be untouched, the next block leveled. There is a mammoth cleanup job ahead for the residents of the 6 states.
Confirmation of this multiple vortex idea came from Neil Ward, working with a physical tornado model at the National Severe Storms Laboratory. In a process known as vortex breakdown, air, which usually moves upward inside a funnel, is pulled downward. Vortex breakdown can lead to multiple vortex development. After vortex breakdown, the outer wall of the tornado becomes thinner. In that thin outer wall, a certain critical value may be reached. When the ratio between the rising or vertical wind speed and the speed of rotation reaches a critical value, multiple vortices are a natural product. The Neil Ward model was perfected at Purdue University in the 1970s. It can produce multiple vortex tornadoes in several forms. With 2, 3, 4, 5, and even 6 multiple suction vortices, allowing for very detailed airflow studies. Here, smoke is entering from the top of the model, revealing the downward movement of air in the center of the multiple vortex. This would not be clearly photographed in an actual tornado for many years. But Professor Fujita found confirmation of the idea in the study of some large dust devils. This dust devil in Arizona and this one in New Mexico have an obvious multiple vortex structure. Multiple vortices were recognized in 1973 here at Lindsborg, Kansas, and a few minutes later at Salina. But it wasn't until the so-called super outbreak of 1974 that they were clearly photographed for detailed study. First in Indiana, then in Ohio. At Xenia, over 2,000 homes were damaged or destroyed, and 34 people were killed. Within this whirling complex, Professor Fujita found what might have been twin suction vortices. During the next 2 decades, as motion pictures and videos became more numerous, it was obvious that multiple vortex tornadoes were not rare at all. To the contrary, they have proved to be quite common. Still photography was just not able to capture the more short-lived, subtle, and easily obscured features of the multiple vortices. The various forms taken by these multiple vortices are fascinating to watch. Here are some classic examples.
Oh my goodness, look at that.
What is that?
That's a cloud. That's a funnel cloud.
You know what it's not what?
Whoa. No, you better stay here for a while, Jada. Your mom knows you're here. Oh my goodness. I think that's a funnel cloud.
Get those kids in that basement. Get them in that closet.
When you're done, can we get a copy of this?
Yeah. If we live to show it to anybody. Clara Wilhelmy.
Just disappear, you sucker. Get the hell out of here.
It's getting those trees that it hit the last time.
It's going to go to our south.
Heston tornado may have had multiple vortices for much of its life, but they were masked by dust and debris for all but a few seconds. Beginning in the late 1960s, other natural and man-made vortices were studied for clues about the conditions under which a tornado is spawned and maintained. Experiments, such as this 1,000 megawatt oil fire in France, were designed to gain knowledge of the atmosphere in general, not just vortices. Information was gathered about large-scale and small-scale air movements, wind speeds, temperature profiles, life cycles, how and why vortices form, and what the dangers and complications are in dealing with them. Both large and small-scale vortices, created by forest fires, have been under study for decades by the U.S. Forest Service.
During intense burning, most of the fire, or even the entire fire, can begin to rotate, becoming one gigantic whirl, concentrated around a vortex at the core. This happened during a later stage of the Garibaldi fire, which you just saw. Cumulus clouds formed above the smoke column on that fire and produced rain. The rain was heavy enough to put out spot fires that had started downwind of the burn area. Here is another central core vortex that formed during a wildfire near a populated section of California. Before it was over, the vortex injured 4 people and destroyed 2 houses, a barn, and 3 cars. The last of the vertical vortices doesn't have a proper name. We'll call it the tornado twin, because it is probably similar to a tornado, both in structure and in the way it forms. It occurs when convection, or a rising current of air, is very strong. This kind of fire whirl appears to originate high in the convection column on the downwind side and burrows downward until it reaches the ground. It appears to form at the ground because, like a tornado, it may be invisible until it reaches the ground. The vortex then rapidly fills with debris or flame, depending on whether it touches down outside or inside the fire. Remember that all these vertical vortices are most likely to occur on a sunny afternoon with low winds, an unstable atmosphere, and intense burning.
As already demonstrated, dust devils have provided insight into multiple vortex structures. They've also been studied for what they reveal about atmospheric conditions over a desert. Dust devils form under clear skies, with light winds, and are never recorded as a tornado. When the ground surface becomes extremely hot, a thin layer of air becomes very unstable. Rising plumes of heat may be induced to rotate, either clockwise or counterclockwise, and usually under 30 miles per hour. A few dust devils may rotate at 60 miles per hour or even faster. The circulation can grow to an altitude of 2,000 feet or more. Some of the means by which the circulation was made visible in these Arizona experiments did not involve very advanced technology. The life cycle of tornadoes was better understood after water spouts were studied in a project off the Florida Keys. These were true water spouts, not just tornadoes over water. True water spouts don't need a powerful thunderstorm as a generator. True water spouts are spawned from towering cumulus clouds, often with rain showers, along wind shear zones, over warm water. Smoke flares were used to reveal the complex airflow around the waterspouts. The flares show that airflow was not always directly into the vortex. The flow seemed to be strongly influenced by the cool outflow from nearby showers. That cool outflow may have had a role in creating the waterspouts. Instruments were swung through the vortex columns. Some waterspouts were directly penetrated by aircraft. And others were studied in time-lapse. The Florida studies identified 5 stages in the life cycle of waterspouts. The dark spot stage, the spiral pattern stage, the spray ring stage, which is very short-lived, the mature stage, and the dissipating stage. In perhaps the most difficult of all experiments, an attempt was made to directly measure the physical properties of a tornado. This required firing an instrumented rocket directly into a funnel. The complex instrumentation needed to be miniaturized so that the rocket could meet the rigid materials and propellant restrictions set by the military and by the FAA. Yet it had to contain enough propellant to assure penetration of the tornado. The experiment was designed to gather data on the possibility that the strongest tornadoes are driven, at least in part, by heat from lightning discharges. Some renowned physicists believe strongly that there is a significant lightning-driven component to the energy source for tornadoes.
They're good, and we supposedly have everything booted. And we are going to try and get a rocket in it. We're going slowly towards it, but we can see that it's somewhat unstable, and we're going to get as close as we can safely. Everything is checked. motor is booted again. It is fantastic. We've already used up half the film here. We're still approaching it, and I don't care if that movie goes all the way to the end. It's too fantastic a sight to miss. We've got some rain there, which is screwing up the photography. There's no sign of any turbulence. We still have a little bit of the film left to go, and we are within firing range, although it's getting thinner, and fire. We missed. Fine rope at this stage, but we're going to fire. 1, 2, 3, fire. And we're going to try and get in just a little closer this time. See whether we can. All right. 3, 2, 1. Fire. There. Nope.
Some experiments were associated with regulation and safety in the nuclear power industry. One that did not directly involve vortex photography was an effort to understand the penetrating ability of tornado-generated missiles. Rocket sleds were used to propel objects, such as steel rods and telephone poles, at various thicknesses of steel-reinforced concrete. The speeds were typical of, or even exceeding, the speeds expected for heavy debris inside a tornado. The magnitude of the tornado wind speed has been under speculation for decades, even centuries. Since 1957, there have been many attempts to measure the motion of debris and clouds in order to accurately measure that wind speed. This process is called photogrammetry. One first traces the movement of a parcel of dust, a cloud tag, or a piece of debris. Then, distances are recorded and the time between movie frames, usually a 24th of a second, is used to calculate the velocity. A wind speed of 126 miles per hour was measured from movements in the Kona, Hawaii waterspout. .142 miles per hour was measured at Cabot, Arkansas. 144 was the top value in Florida waterspouts. .155 was measured at Salina, Kansas. .159 was measured as this tornado devastated 30 farms and then ripped apart 400 homes in Oshkosh, Wisconsin. 168 was measured in the anticyclonic member of the Jordan, Iowa tornado family. "170 was calculated at Dallas, Texas. A speed of 176 was recorded in the mature stage at Union City, Oklahoma. "190 was measured at Ash Valley, Kansas, at a point about 300 feet above the ground. The wind speed was 114 miles per hour, nearer to ground level. "202 was recorded at Sodorus, Illinois. As in all of these examples of maximum winds, the measured wind speed was lower near ground level. It also might have been higher in a hidden part of the tornado, or in other stages of its life cycle that weren't filmed. The Seymour, Texas tornado damaged only trees and telephone poles on its 11-mile path. But photogrammetry measured winds at over 200 miles per hour. 265 miles per hour was calculated within the complex multiple vortex structure at Xenia, Ohio. The highest recorded wind speed using motion picture techniques was 284 miles per hour, about 1,000 feet above the ground, in a suction vortex at Parker, Indiana. Beginning in 1971, the spread of Super 8 home movie cameras began to provide an increasing number of tornado motion pictures. By 1972, the art and science of tornado chasing had improved dramatically. We were getting better and better at predicting which thunderstorms would likely spawn a tornado, and chase teams were now formally organized. When the Union City tornado touched down in 1973, it was almost surrounded by high-quality photographic equipment. In addition, it was within range of the experimental Doppler radar at the National Severe Storms Laboratory. For the first time, a full set of Doppler radar data was gathered, all coordinated with detailed field observations. It was the closest thing yet to having a real tornado inside a laboratory. Radar probed the mesocyclone structure and found radar signatures of the early stages of tornado formation, none of which are visible with conventional radar. Like the tornadoes at Dallas and Fargo in 1957, Union City was truly a landmark event. Later in 1973, a tornado was photographed in time-lapse as it spun, as so many tornadoes do, out of the southwest edge of a supercell. 3 people were killed when the tornado picked up a 19-foot boat and threw it back into the water. In 1975, At Tulsa, Oklahoma, spring-like weather conditions developed in December. 150 homes were damaged or destroyed, and 38 people were injured. These grainy photographs are typical of so much of the 8mm film shot in the 1970s. Perhaps only 1 in 100 tornadoes is anticyclonic. In other words, it rotates clockwise in the northern hemisphere. In 1975, a large and well-formed anticyclonic tornado occurred near Freedom, Oklahoma, the first of its kind to be so clearly photographed. In 1976, the town of Jordan, Iowa, was nearly obliterated by a monstrous tornado. As it moved along an unusual V-shaped path, it was accompanied by another large anticyclonic tornado, the second to be filmed in about a year. The Freedom and Jordan anticyclonic tornadoes remain as the two best examples ever photographed. Here at Lamont, Illinois, 2 people died and 170 homes were destroyed. The Lamont and Jordan tornadoes, although 250 miles apart, both occurred on the same day. Both took unusual turns, and both were accompanied by anticyclonic tornadoes. They were among the many storms whose damage was investigated firsthand by the acknowledged master of aerial and ground observations, Professor Fujita. By the end of the decade, films of tornadoes were no longer rare, and research projects requiring a closer approach to tornadoes were becoming bolder and more complex. In one project, the goal was to drop a sound recording package in the path of a tornado. The team was fortunate that the funnel was rather small, weak, in its formative stage of development.
Ahead of us, we're going to enter rain, possible hail. Rain curtains wrapping rain curtains wrapping very rapidly. We're heading right into the mesocyclone. We're going to try to get east of the mesocyclone. Very strong west winds.
Straight ahead, since that's what we're heading into, right into the mesocyclone.
Rain, no hail. CG, in the rain, 11 o'clock. Going by the road to Brooksville. By the road to Brooksville, our odometer will be, can you give me an odometer right here? 613.4, very strong winds, rain and hail, moving very rapidly eastward just ahead of us. Watch for possible debris. We're entering a high danger zone. You might, if the wind gets too much to battle, you might slow it down. Estimated wind speed 50 to 60 knots. Rain or hail curtains wrapping extremely rapidly right at 11:30, right ahead of us, and very dark ahead. And maybe we'll have better visibility in just a second. We're driving into a strong mesocyclone. Okay, now be real careful, Neil. Slow it down. This would be where we drive right into the tornado, so be very, very careful.
CG.
Rapid circulation right overhead. Slow down, Neil. Stop. Rapid circulation. About 1/2. Debris! Tornado! Passing right in front of us.
The sound package. Sound package. Get it out. Yep, we went right through it.
sound package. Thing, I'll do it. Let Kelly do it. He knows how to work it. CG. Thunder. See debris.
On one rather special day in 1981, chase teams watched the spectacular finale of the Cordell, Oklahoma tornado, among the most graceful ever recorded. Near Alfalfa, an attempt to launch an instrumented rocket directly into a tornado funnel misfired. At Binger, this tornado grew large enough and was close enough to the National Severe Storms Laboratory to generate an excellent Doppler radar data set. It also reached a new maximum wind speed record for Doppler radar, 217 miles per hour. TOTO, the Totable Tornado Observatory. It was successfully positioned once under an actual tornado. That one tornado was weak, but there were some hectic moments during that successful deployment in 1985.
You all right? Yeah. For God's sakes, hang on. I'm okay.
Watch the lightning. Watch the lightning, folks. Damn, we got a hot dog here. Okay, deploy, deploy, deploy. Let's go. I got the thing. Deploy.
Okay, get this thing up here. You got this?
Grab the hook. Yes, it's off, it's off. Let's go. Let's go. Be careful now. Come on, come on. Got on the ramps. Everybody on the ramps? It's on the ramps?
Yes,
all right. Watch the face. Yeah!
This has got to face to the north. Face to the north. Turn it on. Okay.
No, 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 Mike! North. Look at north. Look at north. Let's get the out of here. Go!
It's right. Go!
Let's go! Yeah. Go! I think we need to go back. Videotape it, then we gotta go back and pick up Toto. Wait a second, though. I think we gotta go north. Let's move it.
Go. Yeah.
Nothing. Tunnel. We have a tunnel. We have a tunnel.
Guys.
Yeah, let's move it. Come on. Okay, let's move this. It's behind us now. We're safe. We're safer. Large, good circulation right now. Good tornadic circulation. Got it. Taking another picture. Picture number 4. Watch right here. Watch right now. Watch right here. There we go. We're getting a large tornado beginning to develop. Picture number 6 of the large tornado developing. Getting close, boys and girls. Steve, let's go across the bridge. Go across the bridge. Oh, this tornado on the ground, if it's not a funnel, it's got to be a tornado. Beautiful. Dry spot wrapping around, taking another picture. Large funnel or possible tornado down directly south, moving across us slightly north-northwest. Watch your safety factor here. Yee-hee! Got it, got it, got it. Funnel dropping. Picture number 34. Picture number 34 for off this thing. A needle funnel forming. Good funnel. Good funnel. Good possible tornado beginning again. Moving, accelerating very quickly, rotating around the edge of the mesocyclone as the funnel. Precip beginning here. I don't want to try any more on this. Okay. It's too dark, it's too dangerous. Let's just go back and get total.
The year 1981 may also mark the last widespread use of motion picture cameras. For another transition was underway, a shift from motion picture film to videotape. This small tornado at Piedmont, Oklahoma, under a spectacular supercell column, may have been the first ever captured on videotape. The Cheyenne, Wyoming tornado in 1979 was the first video to receive national attention as it ripped apart about 500 homes. By the spring of 1985, the home video camcorder had become widespread enough so that tornadoes were not only filmed with regularity by chase teams, but also by people in their backyards.
That's a tornado, yeah, leaves. Yeah, but look at it, picking it up. Go get Dale. Here comes a tornado. Sure is. Holy. That's a tornado. Look at it. Get downstairs. Holy sh**. That's fantastic. Where? They're all tore down. Yeah, they are.
In 1986, an unusual tornado was taped from a television news helicopter over Minneapolis. That video provided a unique opportunity to compare a tornado in nature with a tornado in a laboratory. Downward moving air can be seen in the so-called breakdown bubble area of the tornado at Minneapolis. Vortex breakdown occurs when air, which usually moves upward in the center of a vortex, is pulled downward. Surrounding the vortex breakdown, there may be a helical vortex in which air is moving upward. Soon after vortex breakdown, the downward moving air was surrounded by a helical vortex. These features are rarely seen in nature because most tornadoes usually have either too much dust, too little moisture, or too much moisture. Vortex breakdown did not reach the ground. In the relatively short portion of the tornado, between the breakdown area and the ground, there developed a narrow, intense vortex. This portion obviously had very high inflow and vertical wind speeds. It might be thought of as a single suction vortex. The Minnesota conditions were probably as perfect as we will ever see. In 1988, Hurricane Gilbert provided a good look at an unusual hurricane-spawned tornado, 250 miles from the ocean, and the first to be captured on film since this tornado spun out of Hurricane Agnes in 1972. Despite the massive appearance of the Hurricane Gilbert tornado, it did not produce a wide and intense damage track. Few hurricane-spawned tornadoes do.
We'll move.
In 1989, this very photogenic tornado touched down at Hodges, Texas. Nearby, a new era of meteorological research was opening. The tornado was being probed by a portable Doppler radar. By 1991, the Doppler was being used regularly and successfully. On April 12th, Professor Bluestein from the University of Oklahoma was hot on the trail of a mesocyclone near Enid.
They just issued a tornado warning for right where we are.
Should we set up, Herb? Yep.
No.
No.
Yeah, right over here there is. Right over here, the circulation,
That's
right
very
over
strong.
here. In fact, it's rotating right in through here. We're actually a little bit close. Look at the rotation right in here. See, it's centered right in there. Take out the radar right now. Let's give it a try.
Okay.
It only takes 2 minutes to get it out.
Yeah, really.
It's only about a mile away.
I think we got a pretty good scene right here.
Yeah, it's fairly decent. Let's see if we can get lucky. Spinning around right over here. Okay, it's a very, very nice wall cloud, and the whole thing is rotating. And it could happen anywhere within here.
Use
the foresight now and stay in the funnel.
Whoa, watch it. Okay, you're getting decent levels on the recorder.
I hate this foresight, by the way.
Duly noted.
I'm getting signals to the left.
We're going to get the side load to the truck. Keep that tight circulation in there in CW.
I'm on the left side of that tight circulation. And I'm going to go over. I'm going to cut over to the right side of the circulation.
We have trucks.
Damn it.
Who is that? We're getting side load.
Oh, yeah.
Tripod.
Are you getting any signal on it?
I got signal.
You do? On the funnel?
Yep.
Any high pitches?
There was a fairly high pitch just for a second. I hit that.
Have rapid rotation in the wall cloud, and the funnel cloud is just to our north-northwest. We're packing up the radar, and we're going to move north.
The foresight is still on it, if that makes any difference about
Well,
placement. Oh!
There we go. Now it's off.
Hang on a second. You got it?
He's flagging us down. Maybe. He's trying to get up there with it. Yeah, this is a good picture here. Well, you can look at the tape. Just don't get us killed. We're returning east on 4. That's we're headed right toward it. What's just on up and down, isn't it? Yeah. He's going to stop at this station here. We're going to stop right here. Okay. Good. Touch him down again.
Roll it up.
Oh, look at that.
Okay, you got it? Yeah. Oh, somebody's taking pictures. Hold on. Coming through. We got these things. Put that off.
Recorder starting. Recorder's on. How do you remain so calm?
Who's calm?
Somebody get the Morse Skype. It's on the,
Which mode are you in?
I'm in CW.
Okay, tornado is crossing the path of the radar.
Debris in the air.
Can't find the Morse Skype, Jim. Okay, forget it. It doesn't matter. Aiming right at them.
Jeff, do you have the signal?
Oh, what a classic.
Should I go to FM? Look at the signal here. Is that any good?
Yeah, that's spectacular. Keep on it.
Awesome.
Center right on the funnel.
I'm using this this thing right here.
Yeah, center right on the funnel, 502. Okay? All right, now go a little bit to the left of the funnel. Fine, hold it there. Okay, go back to the center of the funnel. That was incredible.
Well, you got a smile on your face. You got what you wanted, Doctor?
Exactly. Yeah, I hope it worked.
May not be the time to ask you, but how does this compare with other ones that you've seen in recent times?
Good. I'll give it an 8.
An 8?
An 8, 8.5. It was very close and very intense.
Just 2 weeks later, history was made with Doppler radar on a chase near Red Rock, Oklahoma. A tornado that started out as a rather modest and picturesque funnel grew in a few minutes to a monster tornado.
Oh, man.
Tremendous inflow. I am getting some close-ups. Tremendous inflow. Gigantic tornado. Thank God I took today off. Gigantic wedge tornado. Multiple vortex. Couldn't ask for anything else.
Beautiful tornado. Panning back a little. Oh, look at that horizontal. Look at the tube, Gene. Oh, it's beautiful. Beautiful. Oh my God. Oh yes. Oh, this entire updraft is a flying saucer. Panning back. I've got to get this updraft just once in my life. Oh, all the way up. All the way around. Looking east. Looking southeast. Looking due south on Interstate 35. Wedge tornado gonna cross the interstate. Giant wedge. Oh, that is, look at the rotation. That has got to be a violent tornado. Major league tornado. Okay, be careful here. We're gonna pass the damage path in a second. Yeah. That is incredible motion.
The wind speed was measured at 287 miles per hour. The highest ever recorded by any remote sensing device.
Jesus, I couldn't even move this thing steady. Somebody check the, God, that thing is a quarter of a mile away. Quarter of a mile. Dude, over here, I'm not thinking too clearly. Your monitor's kind of screwed up. It's going to the right. It's getting extremely close. Hold on to the moving camera. Keep down the tornado. I'm going to listen to the radar. Okay, ready? Here. Hold on to it. I'm holding on in there. Here. Okay, you have it. No, you got to go picture? Backwards. Get a picture? No, it's just horizontal bars. You have to go backwards. Oh, man. Give it a CW. Hang on, give it a second. What's the good now? What? Why don't you pick that up and get the side of the hand, Doug? This side? I hope I get down the wind side. Excuse me. I can't see the monitor. Can you hear anything? Yell loud. We better go. We're getting soaked in next.
Oh yeah, look at the debris. Oh, it hit him, it hit it. Oh, the house just went down there.
By 1991, highly visible tornadoes in populated areas were likely to be taped in as many as a dozen camcorders. This was the case with the Andover, Kansas event. Caught first by storm chaser Tim Marshall near Clearwater, the tornado finally lifted after 45 continuous miles on the ground.
All right, up here and stop then. Pull over to the side of the road and stop. Oh, hit another house. Hit another house.
This is in Hayesville, Kansas. It's 616. Oh, God.
This is what the Golden Spur Trailer Park looked like intact, less than 10 minutes before the killer tornado swept through Andover. Sergeant Paul C. of the Andover Police Department weaves up and down the streets, warning residents to take shelter.
Some of them were running to the shelter, some of them were running to their cars, and there was one guy that was walking along with his dog.
Paul normally uses his camcorder to document traffic stops. He never imagined using it to record the final moments of terror as the tornado devastated the town he is sworn to protect and serve. After warning as many people as he could in the time left, it was time for Paul to try and save himself.
Don't get this way. It's been on the ground for probably 10 minutes now. It looks like it's going to get up. No, it's just about a half mile fellow. Yeah, all you just take cover. Don't stay out any longer. Go for cover.
When I saw the tornado, it was about to blow me away. I stayed as long as I could. I could see it coming from the northeast, or headed northeast towards me, rather. And when I couldn't go again, when I couldn't make another pass without being afraid I was going to get blown away, then I headed for shelter myself.
Well, I'm at 143rd and Pawnee, and I can still see it. It's stakes at me still on the ground in the Andover area now. It's 81. It just hit my 42. 81, 1840. Turn Andover up. It's got Andover right now. Just hit the chief's house.
Regan, come on!
It's still a little ways away.
It's not that far! Harley, come on, let's go!
You ready?
Get steel, here it comes!
Look at it. Look at his house.
This underground bunker with steel reinforced concrete. Some 200 to 300 people, it's almost unbelievable, were jammed down inside here. They survived the tornado. When they came out, of course, there wasn't much left.
The next member of this tornado family then touched down on a lake about 3 miles east of where the Andover tornado finally lifted. That relatively weak tornado became one of the most famous in history.
We were not expecting it, nor looking for it. A tornado that suddenly appeared almost out of nowhere as we traveled south along the Kansas Turnpike north of El Dorado.
go, Craig, let's go. Listen to the wind, let's go, let's go, let's go.
We thought there would be plenty of time to videotape it, but within seconds, it was looming larger, headed right for us. Jumping back into our car, we tried to get away from it.
Go, go, shoot it. You better floor it, you better floor it. Shoot it. We're all right, just stay ahead of it.
Attempting to outrun it to the only structure within miles, a highway overpass.
Keep going, man, keep going.
Faster?
No. Yeah. Lots faster, lots faster. Lots faster, Greg, it's catching us. You gotta go, buddy.
The twister, though, was gaining on us, and we made it there just moments before it struck.
Get up under the girders. Is that where you want to go? Yes. Underneath the girders. Keep rolling, Ted. It's coming at us. Keep rolling. Hang on, you'll be fine. Hang on to the girders. Hang on, you'll be fine. Hang on to the girders. Hang on, you'll be fine. Hang on to the girders. Don't worry about it. Just hang on. Now what are you doing? Okay, talk to me. You're okay. Talk to me. What happened? It sounded like a freight train. It just passed right on top of us. People very upset. People underneath the girders of this overpass. They're still hanging on for their lives. It was a tremendous rush. Flying debris everywhere. Some people look to be like they're all right, but they have scratches and bruises. Here comes another one. Hang on, Ted. I got you. Hang on. You're all right. Don't put your hand over her mouth. A little frightened. You guys just about didn't make it.
Where was he at? Was he in the car or what?
Yes.
Okay, Alec. He's got a good heartbeat, but he's not awake. He's hit his head. He's got a concussion or something.
Those who did not make it to the overpass were less fortunate. All along the turnpike, there were injuries and wreckage.
Your left hand and your head, okay? You remember everything that happened? Not really?
This man was thrown from his car after it was picked up by the twister and tossed across the highway into a ditch. 30 yards away, a tractor-trailer rig, picked up like a toy and thrown across the highway. The trucker, who was trapped inside, remarkably survived.
You can't describe it. And completely from the far shoulder, rolled all the way over.
How do you feel?
I'd say 5 or 6 times.
How do you feel now?
I like to be alone for a few minutes. Got some thanking to do.
Occasionally, a video is taken that provides new insight into a problem that has been puzzling for decades. One such video was taken in 1990. To understand the significance, a few minutes of explanation are needed. It is not uncommon for 2 members of the same tornado family to be seen at the same time. Normally, one tornado forms and gains strength as the older member of the family weakens and dissipates. The older member is seen here in the distance, and the younger member in the foreground. They are often separated by several miles. The result usually means a break in the damage path. tornadoes rarely last more than 45 minutes, and so damage paths are rarely more than 45 miles long. One of the most long-standing puzzles in tornado climatology involves the damage path of the Great Tri-State Tornado of 1925. The damage went on and on without a break for over 200 miles. Our current understanding of thunderstorms leads us to believe that such a long, continuous path is not possible. A clue to how it might have happened was filmed for the first time near Heston, Kansas in 1990. At about the same time as the tornado on the left was passing through Heston, the tornado on the right was forming a few miles to the north. As the new tornado grew stronger, the Heston tornado, seen on the left, grew weaker. One would expect a tornado family to have a break in the damage track of several miles. However, the two separate tornadoes grew closer. As the Heston tornado began to rope out, it was absorbed into the circulation of the new tornado. This resulted in two separate tornadoes, but with a continuous tornadic damage path. Could the Tri-State have been such a family? We will never know, but at least we now have a possible explanation. Just 2 years later, storm chaser Gene Roden filmed the process again.
Gust front blowing it out, that's incredible.
Really? Yeah.
But it's still vorticity really wrapped up.
Oh, wow. But it's still on the ground. It's a needle, but it's still on the ground.
Get this guy to go the other way so I don't get hit. Thanks.
Tornado on the ground.
Okay. Tornado is just probably
sort of a gust tornado of sorts.
Yeah.
We saw something here that may have been a possible tornado. We don't know that it was.
These new videos are a great help in spotter training, where they provide exposure to unusual or difficult to spot situations. Typical of this is a Louisiana tornado, filmed from the east bank of the Mississippi River and illuminated only by lightning. Although most videos add little to our understanding of tornadoes, each year, one or two will provide either insight or trigger some good discussion. Many will provide spectacle. A few clips will become classics. And if we all act responsibly, no one will lose their life, either storm chasing or being the last one to shut off the camcorder and head for the basement.
Well, look at the trees by the highway.
All right, look at there.
Look at the highway trees.
Oh,
Power line just went out.
power line just went out. Look at them. The power lines, I'm getting every power line out.
This is cool.
Oh, your
Okay.
boat's...
It's very rough.
Shit's gonna
Here it
happen.
comes.
Here it comes.
Here it comes. Here it comes. It's right out here. I'm 10 feet from it, and all the electricity, all the power lines are going. I'm 10 feet from it. I'm 10 feet from it. It is incredible. It's coming across the lake right now.
Come here, Bob. Stay right here. Oh, it's coming right at your house. Look at that.
Yeah. It's coming right at the house here. We're going to have to go in a minute. It's either that or do or die. July 6th or whatever it is.
Unbelievable. I think you can come right here.
You saw all the power lines going out. Here it is.
Okay. Watch out.
Here it is. It's going right out across. You can see the stuff flying.
Don't stand by the windows.
Where's John?
Just totally incredible. It's right outside.
Oh, there goes Bob's boat.
Oh, I hope not.
Whoa, look at that shit.
Okay, get away from the windows. Whoa! Get away from the windows. Tree just blew over.
Wow, look at that tree over there.
Look at the top. Get away from the windows. Get away. Get away. Get away.
Get away.
Get away. Where's everybody?
Where is everybody?
Where is everybody? Where is everybody? Oh my God. Are you guys okay? The windows are totally blown out. The trees.
The docks are broken.
The docks are broken.
Our boat's gone. Our boat's upside down. Our boat's upside down.
Yeah.
Where's our dog? Our dog. Where's our wiener dog?
Okay, that was it. It's devastating. It's devastating. It's just totally shot.
Our boat.
Since 1900, over 10,000 people have lost their lives in tornadoes, and they have caused billions of dollars in damage. Why and where one will form next are important questions, for as our cities grow, so do the chances of a tornado hitting a populated area. A source of mystery and misunderstanding for centuries, it is nature's most violent windstorm. The unique geography of North America makes them more common here than anywhere else in the world. A small area of low pressure, it is usually less than half a mile wide, yet capable of enormous damage. Answers are hard to come by, for this marvel of nature lasts only several minutes and is too dangerous to approach. We must devise methods to study it at a distance. Information from past tornadoes is a place to start, for among other things, it can give us a picture of what areas of the country are most likely to be hit. If our unit area is a large square, 50 miles on a side, then on a long-term average, some part of an area that size, in the yellow, would experience one tornado about every 8 years. In the orange, the frequency would be about one every 2 years. In the red, one every year. And in the purple, more than 2 tornadoes each year. It has been found that the area of highest frequency changes considerably each month. Most tornadoes in the spring occur in the southern states. And as spring progresses, this area shifts to the north and west as warm air penetrates further and further northward, and eventually shifts back to the south during the fall and winter months. To forecast the possibility that a certain area of the country might be hit on a particular day, we need more information than just a yearly average. We need to try to understand the very complex weather conditions that might cause a tornado to form, and then be on the lookout for them. The flow of air in the high-altitude jet streams is important, as are the movements of air masses nearer the surface, and the possible formation of a squall line out ahead of a cold front. For instance, on the morning of June 8, 1966, some of these ingredients were obvious. The isobars and fronts on the surface map showed a large storm in Oklahoma moving northeastward. A strong jet stream was flowing out of the southwest, high over Kansas. At the surface, a squall line developed in the warm, moist air out ahead of the cold front, and the Weather Service issued a tornado watch for most of eastern Kansas. The actual tornado warnings came at 7 p.m. when a funnel was sighted southwest of Topeka, Kansas, moving northeastward. The path was only a little longer than average, 22 miles, but right through the heart of the city, destroying 200 homes. The death toll, which was 17, could have been much higher without the many warnings that were issued and followed. History has shown that these ingredients can combine well outside of the area of usual tornado activity. In June 1953, a cold front and squall line spawned a series of tornadoes in the Great Lakes area, hitting Erie and Cleveland, Ohio, killing 116 at Flint, Michigan, as 200 homes were destroyed on a single street. Weakening at night, the storm spared New York and Pennsylvania. But in the heat of the next afternoon, the squall line reformed and spawned a tornado over unsuspecting Worcester County, Massachusetts. 90 people died and 1,300 were injured. Debris such as roofing material and clothes were drawn up into the thundercloud, carried eastward for 50 miles, and dropped from the clouds onto the Boston area. There was no squall line over Dallas, Texas in April of 1957. Just warm, moist air being drawn in from the Gulf of Mexico at the surface. A low-altitude jet stream also from the south, and a high-altitude jet from the west. The product was 20 tornadoes. And this one in Dallas became one of the most well-photographed and studied tornadoes in history, as it tore a 400-foot wide path across the west side of the city. The causes of each tornado are enormously complex, and much is not understood. But the main ingredients can be identified and forecasted better than ever before. Photography has been a valuable tool in tornado studies. Most photographs have been taken by non-scientists, and usually on chance, for it isn't yet possible to predict the exact location that a tornado will strike. These have given a rather complete picture of the visible life history of a tornado. From the first rotating clouds, to the slow condensation of water to make the funnel visible, although a visible funnel isn't necessary to have a destructive tornado. And to the final stages, as the funnel becomes thinner, elongated, and finally leaves the ground for the last time. The speeded-up photographs of time-lapse photography are now an important tool in many weather studies. These are made by taking single photographs every few seconds or even every few minutes, and then projecting them at the normal rate of 24 each second. This gives a view of a thunderstorm or squall line that can't be obtained in any other way. In June of 1966, this giant rotating thundercloud was being photographed in time-lapse over South Dakota, when the camera captured the entire life cycle of a tornado beneath the cloud on only a few seconds of film. The motion of the storm can now be slowed down and studied at any particular instant. By slowing down the motion of a tornado, we can see in detail the rotation of the funnel and the explosion of buildings into the extreme low pressure. The circulation can be studied by following and measuring the movement of single pieces of debris. In this way, the winds of the Dallas tornado were estimated to be at least 170 miles an hour. engineers studying structural damage, and the overturning of 50-ton railroad cars in the same storm, estimated winds of over 200 miles per hour. Studies of bent high-voltage towers in the Worcester tornado gave estimates even as high as 330 miles an hour. But tornado research can take place well away from an actual tornado. There are many tornado-like phenomena that are more approachable, at least to some degree. The great amount of heat and moisture in the clouds above active volcanoes, like Surtsey off the coast of Iceland, can produce tornado-like whirlwinds. They would make an interesting study and are confined to a small area. But working near an active volcano is obviously dangerous. There is a large whirlwind, however, that can be studied with less danger. The waterspout. Not as large or powerful or unpredictable as a tornado, its entire life cycle can be studied at a reasonable distance from an airplane. Often considered to be no more than a tornado over water, the waterspout is in many ways quite different. It can form from clouds that are no more than a few thousand feet thick, and it usually has a smooth, cylinder-shaped funnel. The winds whirling around the calm eye are seldom more than 150 miles per hour, and are probably created by a very different mechanism than that which creates tornadic winds under thunderstorms. But despite these differences, it is a violent whirlwind, and the closest thing to an actual tornado that can be easily studied. The circulation in and around the funnel is of prime interest. For if the circulation is understood, maybe it can be weakened when a populated area is in danger. It can be studied by dragging a temperature and pressure recorder behind an airplane and swinging it right through the funnel. And by dropping flares on water and tracing the path of the smoke as it is drawn into the water spout. In its early stages, a circulation is present long before a visible funnel appears, and the only visible sign is a dark spot on the ocean surface. Could something like this be true of tornadoes? And could it be detected? Other studies, with time-lapse photography, have shown that waterspouts decay near a rain shower, possibly due to the cooler air near the shower. The waterspout looks as if it will be an important tool in future tornado research. There is an even more approachable whirlwind that can be studied, the much smaller dust devil. These form over hot, dry country and are very frequent in some desert areas. Winds may spiral at over 100 miles an hour, but 30 is much more common. They've been quite useful in studying the movement of air around and inside of a natural vortex. Studies have shown that the air in the very center is moving downward and rising rapidly just outside of the core. This is suspected to be the case with at least some tornadoes and waterspouts. Experiments have been carried out in destroying and creating dust devils artificially, always with an eye on whether any new knowledge can be applied to their big brother. There is yet another possibility: the controllable whirlwind created in the laboratory. There are many different types under study. In this model, air is rotated by a moving screen that surrounds the chamber. Following a basic law of physics, the rotation concentrates in the center and is made visible by feeding smoke into it. The funnel changes size as the chamber is rotated faster. In nature, the updraft and rotation are often produced by a huge rotating thundercloud. The flow of air in all parts of the funnel has been closely studied, along with the effect that explosions have on the circulation. The energy of an actual tornado is so great, however, that it's doubtful that this method could ever be applied in nature. In another model, studies have been made on the funnels that are created when the angle at which air enters the chamber is controlled. By increasing the angle, the funnel becomes larger, and a pair of funnels appear. A further increase creates a family of smaller concentrated funnels, all rotating around a central core. There is evidence that the main funnel of some large tornadoes contains several concentrated areas like this, called suction spots, and that they cause most of the spectacular damage. This particular dust devil shows this same suction spot structure. A group of concentrated whirlwinds rotating around a common central point. In the path of actual tornadoes, it is sometimes possible to see spiral ground markings. These are thought to be made by suction spots as they trace out their path across the ground. The greatest damage would be in the path of a suction spot and could result in one house being destroyed and a nearby one remaining almost untouched. The role of lightning in tornado formation is studied here in a model produced by 5,000 volts of electricity. The funnel is a hot plasma of ionized gas, the heat from which makes the air rise. Great displays of lightning often occur with tornadoes, and at night unusual electrical effects have been reported. All this has led to speculation that lightning may indeed have some role in the tornado life cycle. But still, the problem with this and all models is relating what is produced in the laboratory to the weather conditions around a real tornado. Tornado studies are not limited to the laboratory or even to the Earth's atmosphere. Photography from satellites is now a powerful tool in tornado prediction. The satellite is launched into a circular orbit to an altitude of over 22,000 miles. There it revolves with the Earth, staying stationary above a particular point on the surface. The movement of cloud patterns during a single day can be viewed over and over for clues to tornado formation. These photographs discovered that a 300-mile-wide jet stream of air originating over the tropical Pacific Ocean helped to trigger a tornado outbreak in the Midwest. Sunset and nighttime darkness are moving in at the right as the Earth rotates beneath the satellite. The moving dots have been added to show the position of actual tornadoes that existed under the cloud. On May 11, 1970, satellite photographs showed a line of huge thunderstorms developing over the western United States. This one, over Salina, Kansas, is nearly 100 miles wide. This somewhat smaller storm, developing over Lubbock, Texas, generated 2 tornadoes, taking 28 lives and causing a record toll in damage. Studies have shown that 27 of the 28 deaths occurred in the path of the suction spots rotating within the walls of the mile-wide funnel. These suction spots probably had winds 100 miles per hour higher than those in the rest of the main funnel. As tornado and thunderstorm research continues, the ability to warn a community that a tornado is about to strike is continuing to improve. For instance, the warnings at Lubbock and Topeka and many other cities were made possible by locating the tornado with radar. New radar techniques are able to locate a tornado circulation well before any funnel actually forms. The circulation which produces a tornado often shows up on the screen as a hook-shaped radar echo. Radar, time-lapse photography, water spouts, dust devils, satellites, laboratory models, all are indirect tools in the study of nature's most violent windstorm. The methods of study are limited only by the imagination of people and by the money provided to carry out their ideas. The complex puzzle of why and where the next tornado will strike is slowly being pieced together.